Hi, today's learning target is LT3, which says, I understand two types of weathering, chemical and mechanical, and their causes and effects. In this station, you're going to be taking notes and completing the review questions so that you can help master this learning target. Here we go. So let's first start by talking about what weathering is. Weathering is the process where rocks are broken down into smaller pieces. These are just two pictures that show examples of weathering. Weathering can make holes and arches like this. Could also be breaking down rocks into smaller rocks, such as along a river we find big rocks and smaller pebbles. So why is weathering important? It's important because all the soil that we get on the earth comes from weathering, and we all know that producers are extremely important to all living things and all ecosystems. So is soil, because without soil, plants really can't have a hard time growing. And also, it's important because it is one of the main forces that shapes the Earth's surface. So all these structures here that you see have been shaped by some form of weathering. Okay, so there's two types of weathering that you really need to know. The first type is called mechanical weathering. Mechanical weathering is when rocks break down by physical forces. A physical force is any force where one object moves another object by physical contact. So for example, if you are pushing a box, you are physically pushing it through contact here, and therefore that's a physical force. The first type of mechanical weathering that I want to show you is ice wedging. Ice wedging happens when in warmer climates some water seeps through some cracks in the rock. And then during the winter, the water that's in here freezes and actually expands. You know that when water freezes, it expands. If you've seen a water bottle freeze in the freezer, when you have seen that the ice pushes the water bottle out. So when the water expands here, you can see by the arrows, it's going to start forcing the rock to kind of pull apart, or it pushes the cracks here. And after many, many years, the rock will eventually split open. So that's mechanical weathering because the physical action of the water is pushing the rock. It's a physical force. Another type of weathering, mechanical weathering, is abrasion. Abrasion happens when rocks are grinded and worn away by an outside force. The outside force can be another rock, it could also be sand particles, it could also be water. So in this example, you can see the river water is pushing some smaller particles or smaller rocks against bigger rocks, and it's going to scrape against these rocks, and that's going to cause abrasion. The water also causes abrasion because the force of the water actually tears away or grinds away at some of the surfaces of this rock, and that's why some of these rocks are round in shape. It's because of the force of the water, and that's causing the rocks to wear away. In this example, you can see the wind is blowing sand particles across this bigger rock, and when it does that, it's scraping away at this rock, and you can see the smaller lines that are forming because of that abrasion. Finally, in this example, we have gravity that's pulling down smaller rocks down a mountain, and when gravity pulls down rocks, it's going to scrape against other rocks, and that also causes abrasion. A final type of mechanical weathering is plant and animal actions. So plants or trees, they can grow roots into rocks, and when they do that, it can actually crack rocks open, and that's mechanical weathering because there's a physical force involved. This tree is physically cutting through the rock. Animals also cause mechanical weathering because when animals like moles or earthworms, when they burrow into the soil, they can, scrape against rocks and actually cause them to weather as well. Let's move on to the second type of weathering. The second type of weathering is called chemical weathering. This type of weathering occurs when when there's rocks that break down because of a chemical reaction. Now let's talk about what a chemical reaction is. A chemical reaction is when one or more substances change into another substance with different properties in the original substance. So you probably have seen chemical reactions before. Maybe you've done baking soda and vinegar and you've seen when you mix those two substances together, it produces a completely new substance. It produces a gas and another substance in here. It's no longer baking soda and vinegar. Here's another example. When you put Mentos into a Coke, you know that it produces a chemical reaction. It's going to change the Mentos and it's also going to change the Coke. Here's one more example. Maybe you have seen copper pennies change color, and that's because there's a chemical reaction going on with the copper and the air. And that's another form of chemical reaction. So let's connect this with rocks. So water can cause chemical weathering because sometimes the rocks will react with the water. Now, I don't want you to get confused. This is very different from the abrasion. So earlier I mentioned that water can cause mechanical weathering because of the force. When it pushes against a rock, it can actually erode the rock. That's water mechanically weathering a rock. This is when water is chemically weathering a rock. That means that the water is sitting here, and as it's sitting here, it is slowly reacting with the rocks here and causing weathering. And you can see these little holes here were not produced because the water was pounding against the rock. It happened because slowly over time there was water that was left here and it started reacting with the rock here. Okay, another type of weathering is chemical weathering is acid precipitation. Precipitation is another word for rain. So air pollution releases gases such as sulfuric and nitric acid into the air. When these acids mix with water vapor in the air, that forms acidic rain. And when that rains down on rocks, sometimes that acid will react with the rock and cause weathering. And you can see these are just some examples of what chemical weathering by acid rain can do to some stone structures. Another type of chemical weathering is by groundwater. So groundwater is water that's found under the ground, and this type of water usually contains a small amount of carbonic or sulfuric acid, and it's naturally found underground. So when that water comes in contact with stones such as limestone, it's going to slowly weather the rock. And some of these structures that you can see here, this is actually from a cavern. It's a cave. And these were not man-made. These were made by thousands and thousands of years of chemical weathering over a long period of time. And you can see there's some amazing structures that were formed by the groundwater slowly dripping down the rock. The final form of chemical weathering is by air. So not all rocks do this, but some rocks that contain iron, which is a type of metal, can react with the oxygen in the air. And when that happens, it creates rust. You probably have seen rust on metal surfaces. Here's an example of a rusty chain, and this is the rust on a rock. So there's a chemical reaction that went on here, and the air was reacting with the rock. So the main difference between chemical and mechanical weathering is that mechanical weathering, like here, involves a force. It involves a physical force that's going to grind away at the rocks. Whereas chemical weathering, like this, it involves a chemical reaction. It doesn't really need like an outside force scraping or pushing a rock. It just needs two substances reacting chemically. So finally, let's talk about how weathering can speed up or slow down depending on where the rocks are. So I want to introduce the word rate. Rate is how much time it takes for something to occur. And rocks can weather at different rates. That means it can take different times to weather based on the temperature, climate, elevation, size, and the chemical makeup of the rock. So let's first talk about temperature. Chemical reactions generally happen more quickly at higher temperatures, and that means that rocks that are located in hotter climates are going to weather faster. Okay. Likewise, the colder climates also can weather rocks more quickly because in colder climates, the freezing and thawing action for ice wedging happens more frequently, and that's going to cause the rocks to weather more quickly. Finally, humidity. Humidity is the measure of how much moisture is in the air. That actually also speeds up weathering. So in areas where there's high humidity, lots of water vapor, that's going to cause weathering to occur faster. And that's because water speeds up some chemical reactions. Lastly, let's talk about elevation. So elevation is how high a rock is on the earth. Rocks that are really high in elevation, that means they're on the top of the mountain, will weather faster because at high elevation you have colder temperatures and lots of high winds, and the wind action will cause a lot of mechanical weathering, and the cold temperatures will cause the freezing and the ice wedging, and that's another type of mechanical weathering, so it's going to occur more frequently. Rocks that are near the shore, so a shore is where water and land meet, will also get weathered more quickly because of the wave action. And waves are a physical force. They are pounding and booming across rocks, and so that's a type of mechanical weathering.